Okay, so in this lesson, we're going to discuss how to convert an exponential equation to a log equation and a log equation to an exponential equation. But before we can do that, we need to talk about what a logarithmic function looks like, what it is. All right, before we can talk about that, let's review an exponential function. So remember, an exponential function has this form. So the exponential function looks something like this. So it's f of x equal b to the x. So remember, what makes this exponential is the fact that the exponent has the variable x. So the base, remember, the base can be any positive number, but it cannot be equal to 1. So the base can be any real number that's positive, but not 1. Okay, now when we graph these, so here's some examples from previous lessons of what exponential functions look like. So if you look at these are all functions because it passes a vertical line test. So we graphed this one. We graphed the function e to the x. We looked at the function 2 to the x, the exponential function 1/2 to the x, and so on. Now, these are all functions. It passes the vertical line test. But before we can talk about what a logarithmic function is, we need to talk about inverses. And so this is going to be just a quick synopsis of inverses. Okay, so a function has an inverse if it is a 1-to-1 function. So a function has an inverse if it is a 1-to-1 function. Now remember, a function is a relation in which for each x-coordinate there is only one y-coordinate. All right, so we spend quite a bit of time dealing with functions. So these are all functions. Remember, you can use the vertical line test to determine if a graph represents a function. All right, so these are all functions. But a 1-to-1 function, in order for it to have an inverse, it has to be a 1-to-1 function. So a 1-to-1 function is this. All right, so remember, a function is that for each x-coordinate, there has to be exactly one y-coordinate. A 1-to-1 function says this. For each y-coordinate, there can be only one x-coordinate. Right, so it's just the other way if you want to think about it that way. So a function for each x-coordinate, there is only one y-coordinate. A 1-to-1 function says that for each y-coordinate, there can be only one x-coordinate. All right, now let me go ahead and make this look a little bit better. Okay. All right. Now remember, when we talked about functions, we could use the vertical line test to determine if a relation is a function. So notice that for this x-coordinate, there's only one y-coordinate. For this x-coordinate, there's only one y-coordinate. For this x-coordinate, there's only one y-coordinate associated with it. A 1-to-1 function is a function in which for each y-coordinate, see this y-coordinate right here, there's only one x-coordinate. For this y-coordinate, there's only one x-coordinate. For this y-coordinate, there's only one x-coordinate. So you may say, well, what type of functions are not 1-to-1? All right, so here's an example. I'm going to draw it right here. So we have this quadratic function. So the quadratic function, the way it is not a 1-to-1 function. So this is not a 1-to-1 function. Because if you look at this, if you look at these 2 points here, these 2 points, They both have the same y coordinate, but they have different x coordinates. All right. So for these 2 points, they both have the same y coordinate but different x coordinates. So a one-to-one function says that for each y coordinate, there can only be one x. Okay, so you see there, when whatever y value this is, if this is y value 2, then you see you have 2 different x coordinates. So when we looked at a graph, see you could use a vertical line test to determine if it's a function. You can use what's called the horizontal line test. You can use a horizontal line test to determine if a function is one-to-one. Okay, so determine if a function is a one-to-one function. All right, so for example, I'm going to go right here, and so no matter where I draw this horizontal line, it intersects the graph just once, which means that for this y coordinate, there's only one x coordinate. For this y coordinate, there's only one x coordinate. For this y coordinate, there's only one x coordinate, and so on. So all of these exponential functions pass the horizontal line test. No matter which one we looked at, they all passed the horizontal line test. So an exponential function has an inverse. It has an inverse. An exponential function has an inverse. And it turns out that the inverse of an exponential function is a log function. Logarithmic function. Okay, so that's why we're going to start talking about log functions. So log functions are inverses of exponential functions. Okay, now before we kind of talk about the definition of a log function, and before we can get to this point here, which is what I really want to talk about for this lesson, we need to talk about the definition of a log function. All right, so let's look at this for a moment. So we know that an exponential function has an inverse, and we want to find it. Well, there's a procedure that you can use to find the inverse of an exponential function, to find the inverse of any function. All right, so the first thing you need to do is rewrite f of x as y, so y equals b to the x. So replace f of x with y. Okay, and then once you do that, you interchange the variables. All right, so I'm going to interchange the variables. The y becomes x and the x becomes y. And now the next step is to solve for y. Now here's the issue though. This is the issue. How do you get y by itself when it's in the exponent? That's the issue. See, it's easy if you had this linear equation. So for example, f of x equal, let's say 2x minus 1. All right, so remember this is linear, so this is gonna pass the horizontal line test. So we'll have an inverse. All right, and so you follow the steps that we just did. So f of x, we replace it with y, and then interchange the variables. So x equals 2y minus 1, and then you get y by itself. Now you see it's easy to get y by itself here. You've done that before. So you're going to add 1 to both sides. So I get x plus 1 equals 2y, and then to get y by itself, you divide by 2. And so you get y equals x plus 1 divided by 2. And so this is the inverse of this. It kind of makes sense because if you look at what this is doing, this says I take the I take x, I multiply by 2, and then I subtract 1. The inverse does the opposite. So notice I take x, I add 1. So instead of subtracting 1, I add 1. And instead of multiplying by 2, I divide by 2. Okay, now the notation for inverse will look like this. So you see how this is f of x? So we're going to write this as f inverse of x. So you see that exponent -1 means inverse. So f inverse of x. Okay, but let's go back to this. So you see it was easy to get y by itself here. Here it's not as easy. See, the y is in the exponent. How do you get the variable that's in the exponent out of the exponent? That's the question. Okay, so that's where the definition comes in. Okay, so definition of a log function. So definition of a log function. All right. So the log function looks like this. It will be y equals log of x. This is how you read it. Y equals log of x, and it's going to have some base, and the base will be listed here. So it will be listed as a subscript. So the words could look like this. Y equals log of x base 3. Y equals log of x base 1/2. Something like that. Okay? But remember, the base has to be positive, because remember in our definition of an exponential function, the base had to be a positive number. It cannot be 1. So you'll notice that when you look at the bases, the bases will always be a positive number and not 1. All right. Now, so that's the definition of a log function. It looks like this: y equals the log of x base b. That's how we're going to read it. The log of x base b, and the base is written as a subscript. Okay? Now just remember that the base must be positive. The base cannot equal 1. And you can only take the log if you use your calculator. You'll see that the log, that x here, you can only take the log of a positive number. So x must be greater than 0. So that's how we define a logarithmic expression, a log function. Okay, now this equation right here, y equals log of x base b, log of x base b. Remember, we said a while ago in our definition, if I can find it, we said that the inverse of an exponential function is a log function. And so when we tried to get y by itself, we were having a little issue. Okay? But we do know that the inverse of this is a logarithm, is a log function. So notice when we defined y here, that y that you see here is this y. So now we know this. We know that to solve for y, this is what we get. We get y equals log of x base b. So that's the inverse of this. Okay? All right, now, it's not as easy to understand. This is a very difficult concept to understand. But you just got to remember that this right here, y equals log of x base b, is the definition of a log function. It's right here. Okay, now let's talk about converting. So we're going to talk about converting from one form to the other. All right, now here's what you need to know. So the equations, y equals log of x base b, and remember right here, this right here, and x equal b to the y, are different ways of expressing the same thing, are different ways of expressing the same thing. Okay, and this is what we're going to use. This is what we're going to use for our conversions. when we convert from one form to the other. Okay, so now look at this again. So y equals log of x base b. So here's my base. So notice when I change from log function to exponential, from log to exponential, this base is the same as that base. Okay. Now watch this. So I want to convert this to an exponential. So we say b to whatever's on this side of the equal sign. So b to the y. See right here, b to the y equals the argument. We're going to call this the argument. The argument. So b to the y equals the argument. So b to the y equals the argument. Okay? All right, so let's look at some examples. All right. So, first example, we want to convert each to log form. We want to convert each to log form. Okay, number one. We have 3 cubed equals 27. So we're going to start out with some easy ones, and then the next lesson, it will become a little bit more complicated. All right, but you got to understand these before you can do the next lesson. All right, so I want to convert this to logarithms. So we know that 3 cubed is 27. And so I guess I should have changed, and since these are the same, let's finish this and do another one. All right, so 3 cubed equals 27. So to convert to log form, so I'm going to say equal log. Make sure you put log because I want to convert to log form. So I got to have a base. Okay, so I got to put the base. Let's put the base first. So the base is this right here. So that 3 becomes this. Okay, and then let's think about what we said here. So the base raised to whatever this is, that's going to be your exponent. Okay, so 3 raised to whatever this is, that's your exponent. Well, my exponent is this 3 right here. So 3 cubed equals 27. And so 27 is the argument. And so there's your answer right there. It gets a little bit easier as you go through this. So let's look at number 2. You have 9 to the x equal 88. 9 to the x equal 88. So I'm going to convert this to log form. So I'm going to say equal log. I got to put the base. Well, that base is the same as this base. So that's going to be 9. Now to complete the rest, you're going to say this. 9 to what power? 9 to what power? To what exponent? Well, the exponent's this one right here. So it's going to be an x right here. 9 to what power equals the argument. So the argument is this right here. All right, so make the base look like a subscript. So log 88 base 9. Log 88 base 9. Number 3, we have 67 equal 3 to the x. 67 equal 3 to the x. So we have equal log. Okay, you got to put your base. Remember, write it as a subscript. So the base here is this 3. That's your base. So 3 to the exponent, 3 to the power, which is x. And you got to write your argument. The arguments will be this right here then. Okay. Number 4, you have x to the 6 equal 135. X to the 6 equals 135. All right, you want to convert that to to a logarithm. So log, make sure you say equal log. You got to put the base. The base is what you see here. So there'll be an x. So you can say x to what power? So your exponent is this exponent, so that's 6. And then you need the argument. Well, the argument would be this number right here. All right, number 5. You have 4 to the 1/2 equals 2. 4 to the 1/2 equals 2. All right, so we're going to say log. All right, the base is going to be this base here, so that's 4. So 4 to the 1/2, and then equals, remember 4 to 1/2 equals 2, so this right here is your argument. All right, so that's how you convert a something that looks like an exponential form into a log form. Okay, now we're going to go the other way. So we're going to go from log form to exponential. But it's all it is just using what we see here. That's all it is. Okay, so let's convert. So this is going to say convert to exponential form. Convert to exponential form. Okay, number 1. All right, let's suppose this time we had 2 equals log of 9 base 3. 2 equals log of 9 base 3. All right, so I want to convert this to exponential form. All right, so just remember we did. So remember these are equivalent. So to go from here to here, we say b to the y equal x. b to the y equal x. b to the y equal x. So we say 3 squared equal 9. And it kind of makes sense that 3 squared is 9. All right, so this and these are the same thing. So they're the same, those are same ways of writing the same thing. Number 2, you have log of 73 base 8 equal x. Log of 73 base 8 equal x. You want to convert it to exponential form. So you start with the base first. The base is 8. So you say 8 to the x equal the argument, 73. And that's all you do. Number 3, you have log of 54 base x equal 9. So the first thing you're going to do is you're going to write your base. So the base is x. So you say x to the 9, x to the 9th power equal 54. That's all you do. Number 4, you have log of x base 3 equals 73. Log of x base 3 equals 73. So you write in exponential form, you've got to write your base first. The base is 3. So you say 3 to the 73rd power equal x. And that's all it is. So these are easy ways. So it's not difficult to convert from exponential to logarithm or from logarithm to exponential. It's just a matter of you remembering this. So what I would do first is I would remember this right here, y equals log of x base b. And then in my mind, I would remember, okay, if I want to change the logarithm to exponential, I say I write the base first, b to the y equal the argument. b to the y equal the argument. And that's all you need to know in order to do a lot of what we do with exponentials and logarithms. Okay, so that's going to be the end of this lesson.